All right, so our lesson today is called Congruent Figures. And you're saying, what do they have in common? That they're all so cute. Well, some of them are cute. Some of them are grown men playing sports. But anyways, so the babies are pretty cute. Hopefully what you gathered from this, what they have in common is these are all identical twins. Maybe one of them is that one the same actor in the Harry Potter? But anyway, they are identical is what I was getting at. Because you can be twins but not be identical. So in these, we have some identical twins. And that's what we're going to be looking for all unit long. We are going to be looking for identical twins. Except we're going to do it to shapes instead of people and animals. Alright, so you're welcome to write this down in your notes. Congruent figures have the same size and the same shape. That's not the formal definition, but that's what most students relate to best. So go ahead and write that down. Congruent figures have the same size and the same shape. You do not need to draw those figures. I was just trying to show you that if two figures are congruent, then you can map one figure to the other using translations, reflections, and or rotations. So if you can take a figure, slide it, flip it, or turn it, and it lands perfectly on top, concurrent maybe, on top of the other figure, then you have congruent figures. Those are called isometries, but we're not going to get into that. So if you can perform one of those geometrical transformations, you can slide it, flip it, or turn it, and the figure maps perfectly onto the other one, then you have congruent figures. We're not really going to use that way to prove figures congruent, but it is good to know that that is how some textbooks define congruency. Two figures that can be mapped onto one another using one of those transformations. The transformation we would never use to create congruent figures would be to dilate, right? Because dilation means enlarge or reduce, and that would create similar figures but not create congruent figures. So, congruent figures, same size, same shape, that's the only thing you need to write from that slide. So, with that knowledge, if we were given 5 triangles, I want to brainstorm and talk about how we could check to see if some of these triangles were congruent. What could we do? What could we do on a smartboard? What could we do on a worksheet? What tools would we need? That's what I want to brainstorm. How do you show or check 2 triangles are congruent or 2 figures are congruent in that? Does that matter? Patty paper. All right. So what would we do there? We would place a piece of patty paper on top of one of the triangles, and then we would slide the patty paper, flip the patty paper, turn the patty paper, and decide whether or not those 2 triangles are congruent. So me moving these around on the smartboard, undo, is the same as using patty paper, except in patty paper you can't dilate like I just did. Okay, good. Phew. So if we had patty paper and we were comparing those 2 triangles, what would we conclude? Right? Not congruent. Right, not the same. They can't be, 2 figures can't be kind of congruent. They can't be halfway congruent. They would have to completely map onto the other one. So which one should I check next? See any of them that you think match? Up, down one. So that was this example. What I'm doing on the smartboard would be how you could use patty paper to determine, oh, there we go, and this guy's the odd one out. If 2 triangles are congruent. Okay, let's talk about some other things. What else could you use if you don't have patty paper? And these triangles were on your homework, on your worksheet. Protractor. So what would you would measure all the angles and see if they match? Would that be enough? Would you need a ruler too? Could you measure just the angles? Do you have to measure the sides? We're going to talk about that much more tomorrow, so let's just leave it at that. How could we check for congruency? We could put one triangle on top of another and see if they line up. We could measure the angles and measure the sides and see if we get the same numbers. Okay, we're going to leave it at that for today. Here's the formal definition of congruent figures. Congruent figures are congruent if and only if corresponding sides and corresponding angles are congruent. Write it down. This is kind of what I was getting into when I was talking about two figures can't kind of be congruent or sort of be congruent. They either are or they're not. It's a yes or no question. There's no maybe here. So all of their corresponding sides would need to be congruent and all of their corresponding angles would need to be congruent. So what does corresponding mean? Corresponding is kind of, I like to think of it as meaning the sides that go with each other. So corresponding kind of means goes with. If I were measuring these and I were trying to figure out if these were congruent, if I measured that angle right there, what angle would I compare it to? I'd compare it to the one it corresponds with, to the one that goes with. I wouldn't compare that angle and measure it against that angle right there because that's not its corresponding angle. So the corresponding angle is the angle that it matches up with in the other figure. If you had two identical twins next to each other and you were determining if they were twins or not, you wouldn't compare someone's eye color to the other guy's hair color. You would compare eyes to eyes, hair to hair, height to height, right? You wouldn't compare someone's height to the other person's weight. Those wouldn't be corresponding parts. So corresponding just means compare this angle to this angle, compare this one to this one, compare the length of this side to the length of this side, so that you're ensuring that the figures are congruent. That's what corresponding means. It means match them up. You have twins in your French class. Very cool. Okay. So here is our first example. Okay, so what I wanted you to do on this problem, I gave you some angles, and I wanted you to find out which angles they were congruent to, which angles they corresponded with. Now, using pictures are great, but the problem with this picture is that we don't have any markings on this picture. I don't see tick marks, I don't see arcs, so you would have to kind of guess and go off of how big or small each angle looked, and I never want you to do that. So what I want you to do every time is look at this statement right here. Believe it or not, that is a statement. It says, it's a full sentence, it says, triangle TRI is congruent to triangle ANG, period. It's a sentence, but it's in math language. That is called a congruent statement. Say it out loud. Congruent statement. I'll pretend you're saying it. The congruent statement never lies. It's not allowed to. It never lies. So you may always trust the order that is listed in there. So what do I mean by that? Take a look at this first angle. Angle in. So I go to my statement that never lies, and I look and see, oh, in is listed second. Then I go to my other triangle. Which other one is listed second? It's R. So angle in is congruent to angle R. So on and so forth. I, where are you listed? I is listed third. G is listed third. So I, it's bothering me that those aren't pretty. I is congruent to G. And then, of course, process of elimination, A is listed first, and T is listed first. So that's how you decide which ones match up, not trusting the picture or your eyes, but trusting the congruent statement. Okay, so we're going to try it again with our next one. Okay, same thing when we're dealing with sides. We're not really going to reference our picture because we don't need to, but we're going to reference the congruent statement. GA is listed third and first. So we need to name ours, listed third and first, from our other triangle. Now, here's what I want to enforce. It would be nice if you list them in the same order, like GA, third, first, IT, third, first. But it is not wrong, if you list it in the other order. You're welcome to call it TI or IT, because those are the same segment. So you don't need to, does order matter here? Absolutely. Does order matter when you name a segment? No, it doesn't. Although it is nice if you name them in the same order for continuity. Let's see, RT, listed second, first, and G, second, third, so RI would be second, third. Awesome. I think we totally understand this. Let's move on. Why I wanted to play this liar, liar click was because he tries with all of his power to tell a lie, and he can't, because his like daughter wished that he couldn't lie, and so he has this like spell on him or whatever. I wanted to compare that to a reminder that the congruent statement cannot lie. It's always in the right order, and you can always trust the order of the congruent statement. All right, so our congruent statement has been started for us. Triangle, U, N, T. So we look at the picture, and we want to make sure we go in the same order that they went in. They started at U, they went across 3 tick marks, and then they went across 1 tick mark. Across 3, and then across 1. So we need to do the same thing. They have to match. So we start at a point. Which point should I start at? Well, I have to go across 3, and then across 1. So G is my starting point. E is my middle one, and N is my ending point. So we have to name them in order, and the tick marks were there to help us. I like these a lot better because we're given angles, we're given arcs. And arcs are easier to deal with because you're not having to like travel around the triangle. So Y, Z, X. Y has double arcs. So I go to my other one and I find one with double arcs. Y goes with N. Y is corresponding with N. Z, 1 tick mark, so I find the one with 1 tick mark. Z goes with L, and process of elimination, 3 tick marks, 3 tick marks. N, L, M. Doing good. All right, go ahead and try this one. All right, so now we're actually going to use congruent figures to solve for something. All of class, we just talked about them being congruent, but when do people ever use this? Why do we need congruency? So now we can actually solve for something that's missing. We're going to go back to our congruent statement. AB is listed first and second. CD is listed first and second. CD is 6 centimeters. That means AB is 6 centimeters because the corresponding parts are congruent. Angle ABS. That's a very fancy way of asking for angle B. And so angle B, when we look at our picture, darn, it's not labeled. We don't know the measure of angle B. Then we look at our congruent statement, and it goes with angle D. Oh no, we don't know angle D either. So now we're going to use some other things. Let's see. Angle E goes with angle F. If angle E is 85 degrees, angle F is 85 degrees, and now we can use triangle sum theorem to solve for our missing angle. Yep, good job. Did you say it was 67 degrees? We'll do this one real quickly as well. They gave us 3 angles, and I don't want you to jump to the conclusion that, oh, if I have 3 angles, I add them up to equal 180. Because sometimes we do and sometimes we don't. Let's see which 3 angles we were given. Angle B, angle E, and angle D. Those were the ones we were given. Now, if we go look at our congruent statement, second, first. So no, those are not 3 unique angles. 2 of them are corresponding, are congruent, and the other one's the odd one out. So when we decide what equation to use, we're basing that equation off of B being listed second and E being listed second. We are setting B equal to E. And then we realize when we solve that these triangles are not drawn to scale. It's horrible. They're not right triangle. All right, so you solve, you get X is 50. You plug it back in. The measure of angle E would be 2 times 50 minus 10. Okay, whatever. Angle E is 90. Really weird. So that's angle B as well. You know that angle D is 40. So when you're trying to find angle F, you just use triangle sum theorem, and the measure of angle F is actually 50. We okay on this one? I know, they don't look like it. All right, so when we take a look at these 2 triangles, it's looking like they're asking for us to write a congruent statement. So that means that they are congruent. We just need to write them in the correct order. So if I call the first triangle, triangle FBR, then I would need to name the second triangle in a likewise manner. Can you picture that triangle rotating to where F became E? Do you see that rotation? So if F becomes E, then B corresponds with R, and then the R kind of, you reuse it, and it corresponds with L. Earl. Triangle Earl. Okay, so let's solve for some missing angles. Let's look at this triangle right here. That angle is 58, the other angle is 90, so triangle sum theorem. This angle is 32, or we could have just compared that angle to angle L, because we know corresponding parts are congruent. So that would be FRB, done with this one, 32 degrees. What about LEB? Ooh, that's a weird angle to ask about. That's not an angle of a triangle. But we know, because these triangles are congruent, that this angle is 58, because that angle goes with angle F. Those are corresponding. So now we just have to find the linear pair to 58, right? 180 minus 58. Thank you. 122. And now LRF. Oh, so that one, these two angles are complementary, right? So 90 minus 32. Back at 58 again. Cool? Okay. Multiple choice, last one. Most of the examples we did dealt with triangles, but this example deals with what? Pentagons? Yeah, 5 sides. If paint is congruent to house, find the false statement. So you're going to trust your congruent statement, and you're going to find the statement that is wrong. Yep, you got it. You found the false one. C is wrong. It's really, really close. But AI is listed second and third, and US is listed third and fourth. So this one is not a true statement, and the symbol for not congruent is actually a congruent symbol with a slash through it.